Hello and welcome to the Super Professor Podcast. You're listening to Clemons Kunkel, aka Super Professor. And today's podcast is about can we travel faster than the speed of light? And I think we can. I think the answer is yes. And why do I say that? Well, we're already moving. Do you realize that while you're sitting in a chair listening to this podcast, you're moving really, really fast? And let's go to some of the things that are happening right now. Right now, the Earth is rotating at 1,000 miles per hour. So you're moving at 1,000 miles per hour. Are you moving faster than that? Yeah, because the Earth goes around the sun at 66,600 miles per hour. But wait a minute, the sun goes around the Milky Way galaxy at 504,000 miles per hour. Are we moving faster than that? The answer is yes. The Milky Way galaxy falls toward a region of space called Great Attractor. You're going to love this speed. 14 million miles an hour. You're like Superman right now. You're moving really, really, really fast. And we don't even notice it. So, is faster than light speed possible? I think so. But how would we do it? And why must we learn how to do it? Well, if we start now saying that we can do it, because everybody says nothing can travel faster than the speed of light. The speed of light is 186,282 miles per second in the vacuum of space. And like one of the stars, I think, is in a Goldilocks zone. It's roughly 20 light years away from us. 20 light years. That means even if we could just travel at the speed of light, it would take us 20 years to get to that star. 20 years. That means you got to have food or go into hibernation. So traveling at the speed of light is too slow. Because that's, like I think the closest star to us is Proxima Centauri is 4.3 light years. So even the other stars are just way out there. The universe is really vast. And for us just to travel at the speed of light, it's just way too slow. We need faster than light speed travel. So let's do some simple things here. Let's say that star that's 20 light years away, and we want to go there at the speed of light. Well, we can't go where we see it because that star is not there. It took 20 years for that light to reach Earth. Therefore, that star has moved, been moving for 20 years. So, for us to go to that star with the Goldilocks zone planet around it, we have to move the star chart ahead to where it's going after 20 years. Then, if we could only travel at the speed of light, now we must move the star chart again 20 more years to where the star is going to be for us to land on it. But here's another problem. If we travel at the speed of light, time slows down. We don't know how much time slows down traveling at the speed of light. So there's a couple of hiccups and hurdles that we got to overcome. We got to start doing now planning for faster than light speed travel. And why do I say that we can travel faster than the speed of light? Because we're already moving. We know we're already moving. So it's kind of like, and now am I come up with a new idea? No, not really. If you think about in the old days where they took a hot air balloon and fill it full of hot air and it went up into the air and then the air current moved the hot air balloon, all they needed was to get up in that current to move. What else did they do back in the old days? They put a sail on a boat to catch the wind current and move the boat. So when we discovered the New World, the United States, they didn't roll the whole way to get to the United States. They used the wind power to move the big boat. Took them a couple months, but now we just fly in planes to go around the world on vacation. But back in the old days, it took a little bit to get here. So will people go off world? Yeah, they went on a boat and traveled for months, had no idea what was there. We know where we're going. We know there's planets out there, and we know more about every planet as we get closer and closer. We know our planets are in our solar system, but we know about other planets around other stars. We just don't know enough information about them yet. We got a lot, but we still need more information. So think about now. Some people say, "Oh, it's impossible to travel faster than the speed of light." Yes, yes, yes. Of course, it's impossible, and it's also impossible for a germ to jump out of your mouth into another person's mouth. Welcome to COVID-19. Oh, welcome to the virus. Welcome to the flu. It's also impossible to break the 4-minute mile. But now you got to break the 4-minute mile to compete in track. Yes, things are impossible until you break the rules. No, it's not impossible. It's kind of like um, think about right now. You listen to this podcast on information coming in. You don't see the signal. You don't see the information. You're just able to listen to it on a phone or a TV or whatever you got on Wi-Fi. So it's impossible for the Earth to be round, but it is, right? It's impossible, but the Earth is round. We know it. The Earth is not flat. But think about the old days. They thought the Earth was flat. Then it went to being the Earth is the center of the universe. That wasn't true. Then it used to be the sun is the center of the universe, and that wasn't true. So old information you can't hold on to. You might want to hold on to it. You just can't because it doesn't work. Otherwise, we wouldn't be living in space, the International Space Station. We wouldn't be up there. I think the International Space Station falls around Earth something like what 16,000 miles an hour. Think about it. They see sunrise, sunset, sunrise, sunset, sunrise, sunset in one day in 24 hours. So the International Space Station, they don't have a rocket sending themselves around the planet. It's just falling around the planet. So science works. We have to stick to the science. And what is it's like if we could, think about this hypothetically. If we could travel faster than the speed of light, we need to fix our star charts. Because let's say we could travel at the speed of light. If you go to that planet that's 20 light years away and you get on that planet, when you look back at our sun, it's not where we left it because the light takes 20 years to get to that planet that we just moved to. So that's our Earth is in the past. So when we think the Earth is, no, that's we don't see it on that planet from that planet's point of view because the sunlight is 20 years in the past. It's the same thing as looking at another planet, looking at us. That's the past. Everything is we're looking at the past. So we need star charts for getting there and getting back. We need different star charts for every star system we go to in the Milky Way galaxy. Every one. If we visit different worlds, we're going to need a star chart for each different world to get there and get back. And we need to be planning now because we're going to go there. How do I know we're going to go there? We went to the moon. We've been to Mars. We're going. We're 12 people walked on the moon, and rovers and landers and choppers have been on Mars. We haven't had a person on there yet, but we're going to go there. So, are we going to live off world? Yeah, there's no doubt about that. We're already living off world. That's the International Space Station. So, we need to get off Earth. Why do we need to get off Earth? Well, you have you had the Plantaceous period, the Cretaceous period, the Jurassic period, mass extinction. I don't want to go extinct. I don't want the human race to disappear. We need to get off planet because if something happens, we need to be able to come back and help people and recolonize and start over. If you look at the moon, it's beat up for a reason. Stuff hits it. Stuff hits the earth all the time too. We just don't get to see it because of the trees and everything else covering it up. The moon, it just stays nice and pretty and holes in it. We get to see the beating up. So you don't think the earth is beat up? Look at that little bitty moon and it's got bumps all over it. It's not as big as the earth, but if you take that in comparison, think about how much the earth has been beat up. That's the easiest way to figure it out. And also the moon is what's called tidal lock. We only see one side of the moon. It's tipped off its axis. It's looking straight at us. We only see one side. We don't see the other side. We don't. So now, for us to travel faster than the speed of light, um, why do I think we can travel faster than the speed of light? Um, Oh, I published a book, Keys to Unlocking the Universe, on Amazon, where I say that we don't live in the fourth dimensional plane. We don't live in the fifth dimensional plane. We live in at least the sixth dimensional plane. What does that mean? I think other dimensions exist. I'm not talking about string theory, M theory, supergravity theory. They believe in other dimensions, other timelines and places. And I think they're right. There are, but I think they're looking at it wrong. I think we are the sixth dimensional plane. Um, what is a dimension? Um, think about looking at a TV set. It's called 2D. You got forward, backward, left, and right. That's a two-dimensional plane. 2D. What's three-dimensional plane? The IMAX theater. The screen image comes off the screen. You end up with depth. What is the fourth dimensional plane? So if you're sitting in your room, which is a cube or a sphere, you have forward, backward, left, and right, up and down, and you're sitting in the room, you are the fourth dimensional plane. You are matter, and it takes time for you to get from point A to point B. That is the fourth dimensional plane. You're moving in that three-dimensional plane, and you're the fourth dimensional plane moving in an object. That's the easiest way to understand it. What is the fifth dimensional plane and what is the sixth dimensional plane? I said we live in the sixth. Well, matter you have to add to the equation. Thinner space, slower time, heavier matter. I think we are thinner space, slower time, heavier matter. I think we are the sixth dimensional plane. What does that mean? I think our universe came from another dimension. Not part of our universe. I think we came from another universe. And why do I say that? In my book, if you can get my book, it's easier to understand. Um, how do I explain this? Think of an aquarium. Think of an aquarium half full of water, and the other half has air in it. So you got oxygen and hydrogen above, oxygen and hydrogen below. You got other elements, but two different temperatures. The oxygen and hydrogen is not mixing with the water, and if the water cools, it mixes with the air. Two different mediums. One you can breathe in, the other one you drown in. Just think about that in an aquarium. Half full of water, half full of air. So if you think of the water as the fourth dimensional plane, and you think of the air as the fifth dimensional plane, now how do I add the sixth dimensional plane? If you take an oil dropper, the lightweight, and just put one drop of oil on the water, the oil stretches across the aquarium. You have pressure from the air, pressure from the water, and everything is trying to seek balance with each other. So to me, the oil touching the water is the Big Bang, the release of energy. It didn't explode, it's pressure that is released. All right. So I hope that helps. How do I explain further? Okay, so I think that we came from a merging of another universe. So if you have an oil drop over here and drop oil over here, these two oil will mix with each other. Won't mix with the water, won't mix with the air, but they'll mix with each other. How do I explain that? Think of a force to the left and another force to the right. One is smaller, one is larger. And as they get larger and the force plants more seeds, more trees grow, and finally, those two separate forests join and create one forest. How do I explain that further? The Milky Way galaxy got larger by joining with other galaxies. The Andromeda galaxy is falling toward us, and when billions of years from now, will join with us and make us larger again. But we have the the small Magellanic Cloud and the large Magellanic Cloud one day will join with us also. So our Milky Way galaxy came from a joining. And I'm saying our entire universe that we view came from a joining. I matched the great wall, the great attractor, and the great void. And the cosmic microwave background difference, the two different temperatures. If we had one universe over to the left, one universe over to the right, and they merged, they would create two different temperatures. Also, the gigantic void in space, it shows a merging. So my paperwork, my book, Keys to Unlocking the Universe on Amazon, you can get and to understand more. And if we, let's say hypothetically, just work with me hypothetically, if other dimensions are moving through us, shouldn't we be able to see it? In my paperwork, I say, yes, we can see it. We see dark matter and dark energy that's unexplainable. People say, I'm going to tell you what it is and what it does. Dark matter, there's something in dark matter called a macho. Macho stands for massive compact halo object. It's a lensing effect of a binary star. That lensing, we were looking at a star, and what happened is something that we can't see moved in front of the star, and the star moved toward us and got exponentially large. It went from a redshift spectrum, moving away from us, to a blue in an instant. It's like bloop, it's like came forward. Well, that's not possible. And then as we're watching it, then bloop, it goes back to normal where it was. That was interaction from something that's called dark matter. I say that something, that dark matter, is a black hole from another dimension dragging through our area of space, affecting our area of space. Now they're mapping dark matter. They just don't understand 1 minute's there and then it's gone because the matter, that matter that's affecting space, you can only see it when it goes in front of a star and messes with the light rays. Refracted, pointed, changes direction, changes, from red shift to blue shift. So I'm telling you what that macho is. That macho is a black hole with a galaxy around it that's moving through our area of space. That's the way I understand the universe. I think other dimensions exist. I think they're dragging through us, and I think we see it. We just don't recognize what it is right now. Dark energy and dark matter make up massive amount of the universe. I think dark matter I think makes up 27% of the universe. Now think about that. I know it's not a whole lot. It's only 27%. But dark energy makes up 68%. You know what the other 5% is? That's us. That's us. That's the stars, the galaxy, everything in your room, the houses, the trees, the cars, the boats, everything. Everything, our suns, every sun that we can count, all the stuff that we see only makes up 5% of the universe. We only make up 5% of the universe. I want you to think about that. 5% is all we are. Yep, sorry, that's it. By science, it's only 5%. The rest is dark matter and dark energy. So that means that we're smaller than the other dimensions that is larger than us. To me, that's simple. And why do I say other dimensions exist? Well, if dark matter and dark energy, we can't explain it, but why don't you just give it a reason? Say, okay, that's another dimension. Now we can work things out. Just think about it. If other dimensions exist, we know that through string theory, M theory, supergravity theory, other scientists believe other dimensions exist. They don't, if you don't make the Earth first and special, get special out of the equation. We weren't here before the dinosaurs. We weren't here before the fish. We weren't here before the plants. We're not special. Get special out of the equation, and now you can work things out. Stop putting Earth as the center of the universe. We're not. Stop thinking of us as being special. We're just another being living in the universe. Why would we be special? What's wrong with, why can't everything else be special? we don't have to be special. Get special out of the equation. I think we can travel faster than the speed of light by stepping over to another dimension and stepping back and let the universe move without us. That's what my second book is about. And if you get my first book, I hope I didn't talk too fast, and I hope I explained things a little bit. Um, Faster than light speed to me is possible because we're already moving. Just think about this: if you go to an airport, think of being in an airport and you got escalator going one direction and another escalator going the other, and if you have your luggage and you just set your luggage on one escalator that's already moving, the distance starts to double because you're going one way and your luggage is going another. If we step over to another dimension, let our luggage move, let us move, and then step back, we it didn't take a lot of energy. We're just using what's already moving. That's what I'm saying. Have I figured out how to get over to another dimension? No, I have not. Do I want to figure it out? Yeah. I think we can travel faster than the speed of light by stepping over to the other dimension, not live in the other dimension, just use it for faster than light speed travel. And here's the thing too, if we're already moving at breakneck, let's just go with the simple 14 million miles per hour. When we step over to the other dimension, we're not going to stop moving. We're still moving at 14 million miles per hour plus all the other speed. Plus we have to know speed, rotation, and direction of the other dimension to be able to get back to our Earth or to another planet. Faster than light speed to me is possible by stepping over to another dimension and let space move without us and then step back. And think about this. Kinetic energy has more mass of the particle than can be explained. But if you take our universe rotating and falling into another dimension, that mass of the particle having too much energy, now you can explain it. Now, if you step over to another dimension, you're going to have a lot of energy on you. Then, when you step back, you're going to pick up energy. It's like a gravitational assist to go around a planet to pick up speed with the the ships we sent out into space. We use a slingshot. We go around a planet and use the gravity to pick our speed up. We'll have a slingshot effect when we step over to another dimension because it's going to be a drag and a pull. We will pick up speed. And then when we step back, we're going to pick up speed again. So we will have to design and figure out, speed, direction, and rotation to slow down and pick up so we can match our universe. So that's my idea of faster than light speed travel and how we can. So I hope you enjoyed this podcast. If you want to know more about me, I'm Clemons Kunkel, aka Super Professor. I have a YouTube channel, Super Professor. Clemons Kunkel, CLEMONS KUNKEL. I break beer bottle, wine bottle, and concrete block on YouTube. And how I can do that? Kinetic energies, half time the mass velocity squared. It's all science. That's the reason I can break the block and the beer bottle and the wine bottle. All right. So you guys have a good one. Be careful, be safe. And also, before I forget, man made climate change is dangerous as hell. We need to fix it and we need to listen to the scientists. You guys take care. Be safe.